Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, everyone. So today we want to continue with the second class of the compound, which is the alkene, in which in this class of the compound, firstly we'll discuss on the nomenclature, in which how to give name to the molecules of the alkene. Okay, and then secondly, we will discuss on the chemical preparation, how to prepare the alkene in lab. Okay, or the chemical reactions to produce alkene. Then the third one, okay, we'll discuss the chemical reaction of alkene. And the fourth one is the chemical test or any reactions that become a test to identify the presence of alkene. And finally is the mechanism of a reaction. So let's look at to the alkene. Okay, it is known as the unsaturated hydrocarbon. Okay, we have discussed on the saturated and unsaturated hydrocarbon. Okay, when we have a multiple bond, at least one double bond, okay, or triple bond, okay, they are under the category of the unsaturated hydrocarbon. Okay, with the general formula of the CnH2n. And the functional group of this alkene is the carbon-carbon double bond. So there are two methods to prepare alkene. Okay, the first one, okay, from the starting materials of the alcohol. Okay, and the second one is from the haloalkene. Okay, so let's look at to the first one. Okay, from the starting materials of the alcohol. If let's say we have an alcohol, it will undergo dehydration. Okay, dehydration means that the H2O is released. So when we have this alcohol, for example, this is cyclohexanol. Okay, so the cyclohexanol, we have a carbon at each point here. Okay, and that two adjacent carbon atoms are having hydrogen. Okay, and also OH attached to them. Okay, so when they are reacted, okay, these compounds are reacted with the concentrated H2SO4. Okay, with the temperature of 170 to 180 degrees C. So what happened is the hydroxyl group and also the hydrogen from the adjacent carbon will lost. Okay, so this is what we call as the dehydration reaction, in which when this starting material, okay, lost their hydroxyl and H, they are forming multiple bond or the double bond with them. Okay, so we start to have a alkene. Okay, so in this case, from cyclohexanol, it turns to cyclohexane. And then the second method to prepare alkene is from the haloalkane through dehydrohalogenation reaction. Okay, so look at here, we have a bromoethane. Okay, we have a bromine at the first carbon and then hydrogen, okay, at the second carbon, the neighbor carbon. So what happened is, okay, when this haloalkene reacted with the sodium hydroxide in ethanol in the presence of heat, okay, so bromine and also hydrogen will lose from this starting material. Okay, so when this H and B are released out, okay, so the two carbons will form a double bond with them. So from bromoethane, it is now turns to ethene. So these are two methods to prepare alkene. So some alcohol can produce more than one product of alkene, not just alcohol. Same goes with the haloalkene. Okay, so when we have more than one possible product to produce alkene from alcohol or from the haloalkane, okay, we have to be able to identify which one is the major product and also the minor product. Okay, by following the Sazaf rule. Okay, so the Sazaf rule states that the alkene in which carbon-carbon double bond contains a greater alkyl group is the predominant product. Okay, the alkene that is produced that have more alkyl group attached to the carbon-carbon double bond, it is the major product. That is the meaning of this Sazaf rule. Let's look at to the example that we have here. Okay, so we have a hydroxyl that is attached to carbon 2, okay, in which if it is this alcohol, okay, is reacted with the common H2SO4 with the temperature of 170, 180 degrees, we know that this reaction is the dehydration of the alcohol, in which hydroxyl will come out Okay, hydroxyl will come up with the hydrogen from the neighbor carbon. So in this case, okay, there are two possible hydrogen that can come out together with the hydroxyl group. Okay, it's either it come out with this hydrogen from the first carbon, or the hydroxyl come out with this hydrogen from the third carbon. Okay, so since that we are having two possibility here. Okay, so we will have two products. Okay, the first one, okay, it's either it is produced 1, 2, 3, 4, it produce 1 butene, or the second possible product is 2 butene. So this time we have to identify which one is the major product according to the successful. Okay, so it said that, okay, when we have a carbon-carbon double bond, okay, focus on our carbon-carbon double bond, okay, and we have more alkyl group attached to it. Okay, so in this case, okay, the first product, it has only 1 alkyl group attached to it. Okay, another 3, they are hydrogen. Okay, so the left side, 0 alkyl group, the right side, 1 alkyl group. So all together, okay, this first possible alkene are having 1 alkyl group attached to carbon-carbon double bond. Okay, and then let's look at to the second one. Okay, that is our carbon-carbon double bond. Okay, so look at to the alkyl group that is attached to the first carbon-carbon double bond. It has 1 methyl group. Okay, and then same goes with the other carbon. It is also having 1 methyl group attached to it. Okay, then it has a hydrogen. So in this case, if we calculate how many alkyl groups, so 1 at the left carbon-carbon double bond, and then another 1 alkyl group at the second carbon-carbon double bond, so total is 2. So it means that, okay, these alkene are having more alkyl group attached to the carbon-carbon double bond. So this is the major product. Next, we are moving to the reaction of alkene. Okay, if you look at your table, the summary of the organic reaction, okay, we have 1, 2, 3, 4, 5, 6 reactions of alkene. Okay, so let's go through one by one. Okay, firstly, we have a hydrogenation reaction. Second is the halogenation reaction. Okay, the halogenation can occur in two medium. It's either it is in a CH2Cl2, or the halogenation occur in H2O. Okay, and then the third one is the hydrohalogenation reaction. The fourth one is the hydration. Okay, and then the fifth and the sixth, both of them, okay, are actually under oxidation reaction, okay, in which we have a mild oxidation and we also have a strong oxidation of alkene. Okay, so this is what we have from the table. Okay, alkene, okay, halogenation, okay, it's either in the presence of dichloromethane or it is aqueous. Okay, then if we have a reaction in the dichloromethane, the product will be dihalide. Okay, as for if it is reacted with the halogen, okay, aqueous or in H2O, the product will be halo alcohol. We have hydrogenation, okay, of the alkene, the product will be alkane. Okay, and then if we have a hydration reaction with H2O, the product will be alcohol. As for the last, the fourth one is the hydrohalogenation. Okay, so the product will be haloalkane. So these four, the first four, they are actually the addition reaction. So we have to apply Markovnikov rules. Okay, if we have an unsymmetrical alkene. Okay, this is we will discuss this later. Okay, if let's say our alkene, ethene, CH2 double bond, CH2. So firstly, it is reacted with halogen, Cl2 for example. Okay, in dichloromethane, CH2, Cl2. And then the condition, okay, from the table, it is happen at the room temperature. So the product will be dihalide. Okay, in this case, okay, we are using chlorine, so it will produce dichloro. One chlorine attached to the first carbon, another one chlorine attached to the second carbon, so that the product will be CH2, single CH2. Okay, and then one chlorine here and one chlorine there. Or if we make it in a skeletal structure, so it will be, okay, and then we have one chlorine. Then the second one, reaction with the halogen, let me use bromine, okay, but in H2O, so bromine aqueous, and it is also happen at the room temperature. So we will get the halo alcohol as the major product, which is CH2, CH2, Br, and OH. Okay, this is what we call as the halo alcohol. And then the second reaction is the hydrogenation reaction. So by looking at name, we know that it is when the hydrogen is added. Okay, by using nickel as a catalyst, and then heat, what happened is, okay, the hydrogen atom will be added, okay, to each carbon atom here. It will turn to CH3. And then the next reaction is the reaction with the H2O, hydration. Okay, H2O gas, okay, we just need to follow the table that is given. Okay, H2O gas with the condition, the presence of the H3PO4. Okay, it is happen at the high T and high P. Okay, so we will have a CH2, then we have a H that is attached here, OH at the other side. Or it is actually the same as the CH3, CH2OH. From ethene, now it turns to ethanol. And then the next reaction, okay, is the hydrohalogenation reaction. Okay, so the hydrohalogenation reaction, when it is reacted with the HX, example HCl. Okay, condition, it is happen at the room temp. And then the product will be haloalkene. Okay, we have a CH2, CH2. This is the basic, the starting material. Okay, but no more double bond here. Okay, and then the first carbon will got H, the second carbon will got chlorine attached to it. Okay, so the product of this hydrohalogenation reaction with the HCl will produce chloroethane from ethene. So if let's say we have unsymmetrical alkene, okay, our alkene is not symmetrical, then we have to follow Markovnikov rules. So let's look at to the Markovnikov rule. Okay, Markovnikov said that, okay, for the unsymmetrical alkene, okay, when we add HX to the alkene, the H will attach itself to the carbon atom, okay, with the larger number of hydrogen. H will attach to the carbon with the larger number of H atom. Okay, let's try to do the example. If let's say we have a propene, CH3, CH double bond, CH2. Okay, so this is unsymmetrical alkene. If we try to cut here, okay, the left side is not the same as the right side. Okay, that is what we call as the unsymmetrical alkene. Okay, then if let's say we react it with the HCl and then it is happen at the room temperature, okay, now there are two possibilities. It's either the hydrogen is attached to this carbon or the hydrogen is attached to the second carbon. So just draw both, okay, possible product. So we have the first one, CH3, CH2. Okay, when this hydrogen is attached to this carbon. Okay, so that the chlorine will go to the first carbon. So CH2, CH2, Cl attached to it. Okay, as for the second possible product, when we have a CH3, CH, and then chlorine attached to this middle carbon, and then CH3. Okay, why it becomes CH3? Because the hydrogen is attached to this carbon. So these are two possible products of this hydrohalogenation reaction. Then we have to follow the Markovnikov rule to identify which one is the major and minor product. Okay, so look at to the hydrogen. Okay, the first one, hydrogen, is added to this carbon. Okay, in this carbon-carbon double bond, okay, the first carbon are having 2 hydrogen. Second carbon only has 1 hydrogen. So the major product is when hydrogen is attached to the carbon that have more hydrogen, which is this carbon. Okay, so that the major product will be the second molecule. Okay, so this is major and this is minor. So we have to apply this Markovnikov rule when we have a unsymmetrical alkene in all the reactions, okay? In the halogenation, aqueous, and then in the hydration as well. Okay, for the case of the halogenation in inert, okay, the product will be the same because it produced dihalide. So let's try, if let's say we have a hydration reaction, it is now reacted with the H2O gas. And then the condition is the H3PO4, high P, and also high temperature. Okay, so we know that, okay, it's either this carbon that will receive H and the other one will receive hydroxyl attached to it, or the other way around. So the two possible product will be CH3, CH2, CH2OH. Okay, and then the second possible product is CH3, CH, okay, OH attached to this carbon, and CH3. Okay, so the major product according to the Markovnikov rule is when the hydrogen, okay, from the H2O. See, this is how to for us to remember it. So it will break here. Okay, so the major product when this hydrogen is attached to this carbon. Okay, because this first carbon already have 2 hydrogen attached to it as compared to the second carbon that only has 1 hydrogen. So the major product will be the second one. So label it as major, and this is the minor product. That's on the Markovnikov rule.